This video contains an introduction to Laboratory 1 for RBE 2001, and on the Canvas site you can find a PDF which contains the lab, and then you will also find a worksheet that's in a doc file, so that way you can just go ahead and copy and paste stuff right into the doc file. We will provide a printout of just the first page, and the idea is that you'll be able to add your team members, and then as you get your sign-offs, you can then just take a picture, say with your cell phone, and paste that into this box here. Notice that included in the sign-off will be that you've watched the pre-lab video, and then done these inversions, 4 inversions for the Grashof 4-bar, 1 for the non-Grashof 4-bar, and then 1 inversion for the slider crank, and that you've also demonstrated your 6-bar assemblies, SolidWorks assemblies, and you want to make sure that each member of your team does a different inversion. And we'll talk a little bit more about that in just a second. So for the pre-lab, you can see you need to review the material on the wiki, watch this video, and also make sure that you've completed watching the SolidWorks videos and taken the SolidWorks introduction quizzes. So as I already mentioned, for the Grashof 4-bar linkage, you'll do 4 inversions. And let me just point something out here on the wiki. They show you can see this picture of a 4-bar mechanism here, and so you're going to trace out a point on the coupler. So this is the coupler, this right here. Make sure when you sketch this you draw these little 45-degree lines just to emphasize which link is the grounded link. Now you do not want to trace out, so this one is, the pencil is actually in the joint. You don't want to put the pencil in the joint on either side of this link. So you want to put the pencil someplace in between on the coupler. And the reason, of course, is that if this is the grounded link and you put the pencil either here or at this joint here, you're just going to get either an arc or a circle, which isn't particularly interesting. So let me show you using the Norton linkage software what I'm talking about. So here's the Norton software, and right now link 1, that has a length of 3, so from here to here is 3. This is link 2, that has a length of 1. This link has 2, and this is 2.5. So if I run this, okay, you can see that's, if you try to trace that point, you just get a circle. If we trace this point over here, so I'll just change this distance to 2. Okay, so now we just get an arc. So you want to actually trace out someplace in between those 2 points. So I'll put in 1.5. And you can see now it's a more interesting path. And this path is actually kind of neat, because suppose this was a hook and it moves out and moves forward, and then you're grabbing something, and you can see that this part of the path is pretty straight. So it's off a little bit of a straight line between, say, this point and this point, but pretty straight. So that might be a useful thing. I'm also going to put in, let me put in for the coupler, this would just be 2 units away from this point, and I'll put it at 60 degrees. So that's basically, you know, an equilateral triangle. And now if we run that, you can see again, you get a path where it moves out and then comes back down, and then you get a pretty close to a straight line here. So I think that's a pretty interesting path. You'll again plot out the path for all 4 inversions of the Grashof 4-bar. Oops. And then for the non-Grashof 4-bar, you just have to pick one, because none of them are distinct. You can see they're all just rockers for that particular case. And I'm going to have to stop here and pick up with the next video.